These are two of the little transistor radios that were included in a recent barn find. And I thought it might be interesting to see if these work or try and get them to work. Of course, they're total gimmicky novelty. 12 transistors. All you really need for a decent AM radio is 6 or 7 or possibly 8 for a really stellar RF amp and double audio. Well, let's see here. We have two Nobilities, and I wonder if we happen to have a schematic here. That would be nice. Warranty. As soon as it hits the door, I'm sure. Okay. All right. Nothing but the best. And we do, in fact, have a schematic. Can you imagine how impossible it would be to find this if you were not having it? Because transistor radios have transistors that make them transistorized. Therefore, they're solid state, because solid state transistor radios have transistors. And the more transistors they have, the more transistorized they are. And that's what makes them transistor radios. Sponsored by your VP. Anyway, let's see what we got here. So we have converter, IF1, IF diode, detector. Wow, this is a crap radio. So we have converter 1IF, and then we have that's configured as a diode. That's your detector. So this is not even a 2IF stage radio. So this is a total city radio, poor performer. Let's see. So we come out of the volume control through a 0.05. I'm looking for electrolytics too. And then we come into this, whatever the hell that configuration is. We got a 50 microfarad there. Okay. So that's a filter. Then we got a 5 microfarad here, which could be open. Boy, what a... So those are all configured as diodes. See how the collector is tied to the base on those 4 transistors? So what is even the point of that? Is that a phase inverter? Is that what those 4 transistors are making up, a phase inverter? Because it does not use transformers. And then we have a 50 microfarad speaker coupling capacitor. Boy, nobility is the wrong word. This should be like poverty, because this is poor. Yeah, what a joke. I'm going to take a picture of this so it's digitally saved forever. Look at the feedback on the audio. So this is really like, I just don't know what they're doing here. I'd have to sit here and look at this for like 5 minutes to try and figure that out. And that too, like what the hell is that? That's almost like nothing. Like, what is the point of that? I'll try and keep this as stable as I can, but let's really zoom in on this and see what we got going on. So it looks like this is our oscillator coil right here. That's our converter transistor. Okay, then we come down here. Here's our yellow. There's our first IF. And then this is our detector diode. And then it comes over to these two, which I don't understand. And then it comes to those four, which I don't understand what they're doing. And then these are the two audio outputs right here. So really the only valid transistors here are those two, that one, that one right there, and that one right there. The rest of it is really just a joke. What a joke. Can you imagine being the one with the engineering task? Yes, we got to get as many transistors. We got to get the transistor count up. So find a way to wire all these transistors in, because we have to include a schematic, and they all have to be connected to something, and they have to look like they're doing something. Because in order for them to do something, we have to make them look like they're doing something when we install them and connect them to be doing something. More vice presidential ambitions there. I hear some crackling. Okay, well, nothing from the black Nobility. Let's try the red one. Okay, well, these are a little bit different. They had a different lot of floor sweeping transistors. You can see over here we have that. Over here we have a more modern one. But for the key ones, we kind of have the same. Well, those audio outputs are not even the same anyway. Okay, well, we have the same fault with both of them. Both of them just have a little bit of scratchy. So we have a 5 microfarad here, but if that was open, we wouldn't have any scratchy. And if this was open, we wouldn't have any scratchy. And this is just a filter. If that was open, it would probably squeal. I put this up to my ear and I can just barely hear a little bit of hiss. And I tune the thing and there's nothing. So there's a couple different ways we could try and diagnose this. We could get another AM radio that works, set it next to this, tune this, see if we hear the oscillator in the other radio. If we hear this oscillator affecting the other radio, we can get the signal tracer and have a listen to the IF here, to the output. We can see if we hear anything there. We could inject 455 from signal generator into here. We could inject audio into the volume control. I think I might do the signal tracer just because it's easiest for me to get. I do have my little light bulb right here, so I know that I'm not drawing too much current. Let's see what we get.
embargo, también está sucediendo muchas cosas. 또 저 같은 사람이 만드는 거는 또 차원이 틀린 모습.
Okay, so it's only getting a few stations at the top of the band.
Queridos amigos, amigas, 똑같은 감과 있어.
They need a videographer.
Teniendo que lidiar con tantas cosas.
Where's the other lead? It's right there. Sounding good. So why do we only have signal on one lead here? Is this transistor bad? Let's try the other radio. All right, here's the black one. Nothing on this one. I'm getting the same crackle through the speaker though when I give it power. Okay, these are just NPN transistors, so let's do a little voltage checking here. Where's my schematic? So we should just have, I don't know, 6-8 volts on the collector and I don't know, a little bit on the base. The emitter is grounded, so let's see here what we got. This is the lead that had all the signal on it, and this has 400 millivolts. That almost seems like the base. This is seems like the collector because it's got 8 volts. This had no signal on it. So is this transistor bad? Try and get down in here and get to the other one. And this one has 7 volts on it. So how is that possible if one of them is grounded? Well, the power switch is in the negative. Maybe the power switch is bad? We could definitely defeat that by just taking this and going to here, right? That gives us a short. But this shows us as being all NPN. Stand by. All right, well on this one, positive goes to the power switch. So schematic might not represent actual device in case. Let me look this over. Okay, well, yeah, schematic is not exactly right. So these are the 3 leads from the transistor. Ground. I guess this is ground. Ground. Collector. Base. So this right here is the first IF transformer. This is the second right here. So we have our collector.
Has ensured our communities have access to careers with living wages.
And then this is the output.
And clear pathways to personal and professional construction career. Business ready.
So
our example. Trying to make our centennial mission to rebuild Black Wall Street right here in LA a reality. Those urban leads with your time. Donations. Visit laul.org. That's L.
So then that should come over to here.
On KBLA Talk 1580.
So from here, where does it go? Is it just an open capacitor? So where does it go from there? Okay, from here it goes to a 1 microfarad that's not on the schematic, of course. And it comes to here, which it's not coming there because the capacitor's open. It's this capacitor right here. That capacitor is not on the schematic. That capacitor on the schematic is a 0.05. What do they think this is? A high impedance tube set? You know, use a low value like that unless it has something to do with this. And how about that 5 microfarad right there? The schematic does not match.
Bringing some of his fellow gang members onto the brighter side.
Something I'm curious about here, which I think is a more serious problem. Why is it only picking up stations right at the top of the dial? Watch what's going on here.
Because
That's almost like the tuning capacitor is bad. I mean, it could be the transistor or something else, but...
understand, listeners, why...
Okay, well, if I jump from there to there, which is bypassing those 2 weird transistors that are just in there, I do get something. So I think what I'll do is just start by recapping this. Hopefully it'll fix it. The schematic is just way off. Way off. The values are way off. Not I don't think the actual, the drawing is off too. I went through with the capacitor tester and I checked and replaced all the bad electrolytics, and I just used, not going to use new ones in this thing. And like I expected, it when I first powered it up, it worked distorted for a second and then it stopped. So Are we going to fix this? If we are, maybe we should put a commercial break in right here, because this could be a long one. Go get your favorite Horstduvers and something to drink, and we'll be back. All right.
We both need to get on it. Cause some of these brands, I need to like my suitcase, Soul Guard, that little luggage that.
Soul Guard. All right, we got a problem here with this 2 transistor preamp.
I'm like so in love with that brand, you know. So yeah, if you're looking, how would I do that? You think?
See, it's not coming through these 2 transistors. See these 2 leads right here, and that lead. Let me do this. Again, the schematic is like kind of wrong and kind of right. This is like an NPN version, and this is a PNP version. So these 2 wires right here are these 2 wires right here. This one and this one. This one right here is this. This point right here and this point right here is this point.
Nail artist who never does their nails, 'cause like I know all these things.
And this point. See how that's much less? There's a problem right here with these 2 transistors. One of these is bad. But that's not the only problem. There's other issues with this radio. It should be much louder right here than it is here. Because this is actually biasing this. This is like positive, and then here it's just drawn upside down from what we usually look at. Listen, I'm going to jump over those 2 transistors. New up-and-coming social platforms. Well, this transistor that's in there as a diode is shorted. And yes, you can use the capacitor wizard to look for shorted semiconductors. It's very good at that. Here's what I want to do. I want to take this and use compressed air to desolder these. Basically, I'm going to tape it off, and then we'll heat them up and use compressed air to blow the solder off. Solder wick is expensive, exceeds value of radio, and it'll keep me from getting the parts too hot. It's just like heat it up and then blast it with air. Heat it up and blast it with air. You don't sit on it and bake the parts. But I know that these 2 transistors here are bad. These 2, the ones that say USA on them. And I can't believe those are USA. None of these have numbers on them. I don't know if they're NPN or PNP. The schematic does not match the set. It's like everything is flipped on this. It's like the schematic was for an NPN set. This is a PNP set. But definitely there's a problem right here. This transistor right here is this one right here. This one right here is this one. This one here, your first audio. Well, I guess this is kind of your first audio and your second audio. This one right here is the little small one right here that says P4 on it. So I'm going to take these 3 out and just test them. I know that one's shorted. These 4 right here are these 4. This shows 1 NPN and 1 PNP, and that, see, these are all NPN, which might be the case because one of these is different. But Anyway, these four here are these four. And I'm still not really sure I understand the point of that. They're basically diodes. Those are basically configured as diodes. See, base and collector are shorted together, base and collector are shorted together. So this is basically the two diodes in parallel. Let me look at this. Yeah, I mean, this is basically two diodes in series and two diodes in series and then parallel. But why do you need them paralleled? I could understand two diodes because that sets up your voltage drop, right? So if there are two silicon, which these are germanium. So if there are two silicon diodes, that would be like 1.2 volt drop. If it's germanium, it'd be like a half a volt drop. And they're just in parallel. So what the hell is the point of this damn thing? It's just to get the transistor count up. There's like no point. And it's the same as this. What the hell is the point of this? This is going to set up a certain amount of drop. Why not just use a resistor there? Yeah, I think it's just all about getting the transistor count up. But the problem is now you got a lot more parts to short. So you increase the unreliability. This is like game controller submarine style crap. Well, there's two of these for sale on eBay. And this one says, with case works, veteran owned. I don't know what veteran owned. I don't know if that improves anything, but maybe it does. I don't know. This one does not say if it works or not. Yeah, I mean, this is really polishing a turd. You know, if I was getting paid 10 cents an hour, I would have already exceeded the value of the radio. I've been out here playing with it for, what, 3 hours? 4 hours? It's going to have a bunch of bad transistors in it and who knows what else. But we're going to get to the bottom of it because that's what we do. What we do here. We polish turds. Just pop right out now. Well, this one, which is the first amp after the volume control, tests okay. Boy, the beta is really low, 8. And these are PNP, where the schematic shows them all NPN. This is the second one, the one that says P4 on it. This one tests okay too. Really low beta. I want to see if I can show some of the afterthoughts on this. See this? See how they just drilled a hole there and bent that over? This one is shorted for sure. But look at the same thing here. See how it comes through a hole right there? Yeah, this is an afterthought radio, but see how nice that cleans up when you use air? Just makes a mess. You have to clean all the splatter off. Why wouldn't I be?
That's good to hear. Well, has had a Google business profile set up. Well, do you remember getting that done?
That's favorite Wazer Breathless?
I'm sorry?
This crazy Wazer Playlist?
I'm sorry, I'm having a hard time hearing you. You're voice is breaking up.
There's
Can
Venus
you please
Kreis Phenol Blazer.
I'm sorry, Paul. I can barely hear you.
Nicroin Dropalopal Flosher.
Okay. Have a good one. I'll just try to call you back, Paul.
Anyway, I'm starting to notice a pattern here. We got popcorn going in the background. Hot butter popcorn. God, I lost my train of thought. Oh, okay. All of the transistors with the red dot on top, all shorted. I'm slowly sorting this junk out in my head. This is a series parallel circuit. 2 in series, 2 in series, and then parallel. That's not how it is in here. They're all in series, and 2 of them are shorted, which I think they might intentionally be shorted. Just like this one here is shorted, and I think it might be intentionally shorted just to get the transistor count up. I don't want to call it a dummy transistor, but it sure is suspicious that just the right ones are shorted. I don't know, I put it all back together. You know, it makes sense to me. The only thing I can see that might have been wrong was where this wire was bent over right there and soldered, if it wasn't. But let's test it out. I don't know, I don't see anything wrong with it. At least in the audio portion. This thing is a trip. It's got fake, intentionally shorted transistors in it. So it's back to this. It was briefly doing this. And I think that's KNX. Now that sounds like a bias problem in the audio section. So I really think the problem was that popped off. I think that's, but because it was doing this right after I recapped it, but then it stopped. So now what I need is a signal tracer to feed it in and see what it's doing. Well, I think it's this transistor's bad. This one is shorted. I don't know if that would cause a bias issue. I think this is supposed to be shorted. That 150K is good, and that's what biases this. If I add more resistance to it, it sounds better. Listen. I don't think lifting that up, I don't think lifting the emitter up a 0.5 volt, would that affect anything? Would lifting the emitter, maybe we put a diode in there and see. This thing is a trip. So I lifted that. If I bypass that transistor,
Next in depth. $900 million is nothing to sneeze at, even for the size of Disney.
So that's the transistor that had a beta of 8. I bet it's leaky, and I think we need to change it. Running the thing through a diode or not doesn't seem to matter. I mean, I can go through this diode and which would lift the emitter up like 500 millivolts, and it's still just distorted. So yeah, we need to replace that transistor. This is just a 2N2907. Look at the gain on this, 179. It's PNP silicon, but this should sort of self-bias.
Boulevard, still heavy down towards the 90 and really
Well,
coming
that
south
did it.
into Carson, especially from Artesia Boulevard all the way down to Alameda. That's going to be the toughest stretch for you on this 405 freeway. The 405 in Orange County. Let's take a look and see how you're doing. You're looking pretty good through Irvine.
So now I'm looking at the oscillator with the scope, because as we first discovered when we were working with the signal tracer, that it seemed like it didn't get anything on the lower end of the band, and sure enough, it almost has like too much gain. So this is the frequency right here. So I'm on KNX 1070, so it's 1070 plus 455. So I'm speeding it up. See, it gets bigger. Now watch as I'm going to turn the volume up. Well, now I'm going to start tuning down lower on the band. Watch. And there it just goes away. And that's the bottom half of the dial. Right there it starts. So it seems to start right about... It seems to start right about tuning right about 800, 900. So it's either the transistor is bad, or it's an alignment problem. But it almost seems to work too good to be an alignment problem, because KNX is right on the dial here. So this is a weird one. You would think that if it was a transistor, it would be the opposite. It would stall out at lower frequencies, it would stall out at higher frequencies and work at lower frequencies. These are the problems that are just out of control, hard to figure out.
In Disney animation, do what they did for years.
So I'll take this off. If I could get it off. If you just listen here. And right here, the pointer would be right here where my finger is.
Like for students who suffer, especially
so that much is the whole bottom half is not working, half turn. And I don't think it's a tuning capacitor problem. We can kind of prove that by finding the point right where it stalls out and then turning the trimmer capacitor. I replaced the transistor with just a generic, like a 2N2906 PNP silicon. This is a transistor that was in there, and it behaves a little different. I'm using a 100X probe because I don't want to load it down, but I'm going up the band. I'm going to move it pretty quick. So it has these spots where it does this. So I'm going down the band. And then at the bottom of the band it's doing this. Now next thing I'm going to do is I'm going to try bridging this IF transformer with a capacitor, because I I ran into this on another radio where the yellow IF transformer, the capacitor was open. This is the capacitor I'm talking about right here. It's inside the IF can. It's pretty standard. I think it was 168 picofarads on the other one. Okay, all adding a capacitor did there was kill the performance. It's still doing the same weird...
What it is calling a groundbreaking initiative to bring men's ice hockey to an HBCU. TSU's athletic director, Mickey Allen.
We're bringing hockey to the...
It's weird how it's doing that.
All that Wendy's chili.
Did you already eat?
Actually, I think it is a transistor problem, because without the scope hooked up, it still misbehaves, but that was KFI 640.
Marcus, hey, amigos.
failure because Biden has moved closer to Iran, America's enemy, while abandoning...
So I think it is a transistor, because this other transistor would not run. I'm going to switch them.
Biden policy, and if it continues much longer, we're going to be driven out of the Middle East.
I'm back to the other transistor, and yes, this is definitely a transistor problem, because see how this one just stalls out? Yeah.
Inflated prices.
And the other one was a much bigger signal too. It almost filled up the whole. So yeah, it's definitely a transistor problem. It's just going to be about finding the right transistor. These things can be super picky at converter transistors, and it's a PNP, which is going to be hard to find. But yeah, the other transistor performs much better. It's a generic PNP. I got to start trying transistors. Back to the radio, I brought a bunch of different PNP transistors here. So I figure we just start randomly trying them. Today, the oscillator's just stalling out. It's hardly even running. It's just running right at the very top. So I kind of like this one. It kind of looks like a little mushroom. What's interesting is this one has some leakage and a forward voltage of like a germanium, but let's try it. This is kind of a self-biasing thing anyway, so let's see. Collector emitter base, okay.
Besides the way you went in, if it was feet first, your feet would come out first. Pat, what are you smoking?
It seems very happy with this little mushroom.
747 and visit sellersadvantage.com. Stop by here. The Mets owner keep calling.
Community Center in San Pedro, and the City Hall.
I'm inside of a metal building right now. I'm not, usually outside, but seems very happy with this little mushroom. Wow. So look at it now. Look at how big it is. And there's one part where it goes nuts here. That could just be the scope probe causing it to wig out. Well, look at this. That's the bottom of the band. That's the top of the band. Let me see if that continues if I get the scope probe, because we can hear that, right? Yeah, it goes quiet. It doesn't seem like it does that unless the scope probe is connected. Let's try one of these little Soviet transistors just for the hell of it. But the mushroom one looks real good. Hey, here's a little Russian one. I think it's a KT361. And it runs across the whole thing, but I think the other one was bigger. I think the sine wave was bigger. Okay, here's a different Russian one. I forget the number of this. Let's see, our peak to peak is around 0.15. Let's go back to the mushroom. Back to the mushroom. Look at this. 0.25. The mushroom is hot, baby. It's one hot mushroom.
Flights either delayed or canceled.
I think the mushroom is germanium. Mushroom's cooking, baby. This is a 2N5086. You can see the mushroom is much more flat, although this is overall a hell of a lot hotter.
I'm Wayne Resnick, part of the morning crew. The whole morning crew is here. Wow, there's a lot going on before we even get to this first topic. Number one, in today.
See how critical this damn converter transistor is? These things are really, really finicky about that transistor, and that is the main front end transistor. So this one is definitely bad, without a doubt. That's what was causing the issue. But you see how damn finicky these things are.
With our 101 signaler, if this is still here, only a right lane.
I mean, this one overall seems to work pretty damn good. I mean, the mushroom's a little flatter. Let's try another one here. Why not? Let's keep this party going. See, this is a Soviet one. Any of these would work. Let's try this one. This one is a PN4250A. Doesn't like this one at all. Headphone lover special. That one's a headphone lover special.
And the University of North Carolina, a public institution, violated the law by using race in university admissions. Legal analyst Jessica.
I don't know. It's really a toss-up between the mushroom, and the mushroom does not have a number on it, and the 2N5086. The 2N5086 is definitely a little bit hotter at the top of the band. The mushroom is pretty flat. So, yeah, it was definitely this transistor that was causing the problem.
School started thinking about, can we accomplish the same thing without explicitly considering race?
I don't know, I'm pretty happy with the mushroom, and I have a whole bag of them, so no idea what the number is on it. No idea. Solo mushroom. And it's cute. I took it outside with the mushroom, and it's hot. And it hasn't even been aligned, and it's going to be really hard to align it and get it like it was originally because the oscillator transformer has wax in it. And yeah, but it's working really damn good with that mushroom. I'm going to install it. All right, there it is. The mushroom has been installed. And that was a military aerospace surplus transistor, so that's way more valuable than the whole radio. I have no idea, no numbers. I want to check the other radio. These two are shorted. Like I said, these four are in series. They're not in series parallel. So that one is shorted. And I swear these were intentionally shorted because usually transistors don't short base collector, base emitter, emitter base. They usually don't short all three together like that. So they might have done this intentionally. So I want to just pull the other radio apart. So we changed 3 electrolytics and 2 transistors. That transistor, the audio amp, and the mushroom. Okay, here's the one we just fixed. I'm going to see if those same transistors are shorted on this one. Ooh, quality control. Well, this one's even better. So, screw even shorted transistors on this one. They're just bypassed. See this? This one's just jumpered. This is the emitter transistor on the audio driver. And then 2 of these are just shorted. These 2. So it's the same thing. They're just using 2 as diodes. So this is the original converter transistor. It's an FCS 1542. If I put that in here, the first thing that comes up is 1960s Fairchild Dome transistor ID on antique radios. So let's take a look here. 1969 data book. Early on, there were lots of problems with the wire bonds pulling loose as the epoxy cured with the wash as epoxy was injected into the mold and swept the wires loose. Take a second and explain the shorted transistors. So, like I mentioned, they're really in series. They're not in series parallel. So, these 4 right here are transistors, but if you look, they're configured as diodes, and they're really in series. They're not in series and then parallel. So basically what we have is this circuit. This is real simplified. I omitted the resistors and little capacitors. So you really only need 2 diodes here. So they just have these 2 jumped or shorted. So these are, this is all germanium. This is your driver transistor. Like I said, I omitted the biasing resistors and stuff. This is plus. This is your speaker here. So this is kind of a neat circuit because it doesn't use any transformers. It seems pretty efficient too. I'm not sure. I didn't do a milliamp test on it, but it seems okay and it sounds good. So yeah, this is all just to up the transistor count. That's all this is about. And then in the other radio, they just have jumper leads across them. But you could really do it with just diodes. You don't need transistors here. And this just arrived, which this radio sparked my interest searching for different transistors. You could buy this for about $15 shipped on eBay. And here, let's do this. Like the little hyphen on the A, and I love how it's not even capitalized. It's not even worthy of capitalizing the country. $15. Now, you better bet they're probably all the same. I mean, imagine. But for these little crappy radios, I'm not going to undo what we've done, though. I mean, I got that little mushroom in there, and it seems happy. But I bet one of these would work. I'll pull a few out and test them. I bet they're all probably the same thing. This is a BC558. You can see the numbers there. The beta on these things is insane. The beta on the mushroom was like 55. I think these S90131415, these are in those Chinese radio kits. No, these are all 9018. Well, 9013, I think that's in here. Yeah, 9013. These are all different numbers. Yeah, I wonder if they're all the same. Who knows? Well, for 2 cents a piece, they'll be entertaining to play with in the future.
Big program. Can you hear me okay?
Yeah, go ahead.
Great, I'll be quick. Based on your experience company profile, we are offering a limited time offer to access up to $250,000 without any impact on your credit. Rates starting at 3.75% with terms up to 10 years. You may use the funds for payroll, expanding locations, contract fulfillment, or just general bills. There are no limitations.
Scrinal Starfleet Difeifel Gleischalim Nearbon Burval Plurnalermo Blurber. It's AI. It was AI. So many of these calls now are AI. All right, let's give the Nobility, the repaired Nobility a band test here. I know everybody loves this. Maybe one day I'll do the black one in another video. But now that I know what's up with them, I could fix that one pretty damn quick. Look at, they actually have a registered trademark symbol on this thing. This thing all the way around is such a novelty.
Rob, aren't you over there?
Kind of has a little bit of a hollow sound. That's LA Oldies, so that's pretty damn good performance. Let's see if it'll do 690.
Figure out what's going to happen.
Okay, that's 690 out of Baja, California. That's pretty damn impressive. That's pretty impressive.
They'd have to fork the money they'd made that day.
800. Name of the college. We'll see, but as of now.
I think that's Kogo out of San Diego.
We have 3 stories to update. We'll start with the e-bikes. Next, later, let's spread the word. And taking a look at that Thursday afternoon traffic, looks like we've got a new accident on the northbound 5 at Del Mar Heights. This one's block 78 connector. We're about 50 minutes from Mission Valley to Oceanside on the northbound 5. Eastbound 94 at Kenwood.
This is Kogo.
Involving a motorcycle as well. This one's blocked the number 2 lane as you count from left to right. And traffic's going to be heavy from the 125 out through Casa de Oro. And eastbound 8 at Severn in La Mesa still dealing with the crash on the right shoulder as well. I'm Jared Edwards. Kogo's next real-time traffic update is coming up with the news at 6:03. Only merit-based at numbers. car. Is that right? Yeah. Wow. Blake, what's a realistic timeline here? Thank you, Frank. I appreciate it. Thanks for putting that book. For publishing the book. The editors were looking for, changes a little bit more.
But I want to thank all of you. Let's see how far this book can go up with a Levin search tonight.
The Amazon list. Get past all those. Rosita, performed by classical. July 4th. They're disappointing the Mets, the Padres, etc. Take care of the family. And so if I can make up the difference and I don't go backwards financially, I'd absolutely scale back. Because you're really not scaling back financially. You're just scaling back that one
Hours,
job.
yes.
Flavor Friday, end of the night.
Got the wild card spot by the time August 1st rolls around. Or they could see
Wow.
11 games. So
Gets 1090 out of Baja California too. That's 200 and something miles south of me, Mexico, top of Mexico. That's pretty impressive. This thing's actually kind of kick ass. For a 1IF radio, I guess it's just got so much damn audio gain, but I'm a little impressed.
for a baseball section.
되었습니다.團嚟啦，10月11號出發。
미리 제품이기 때문에. 뭔가.
Racial diversity in student admissions, including eliminating athletic and legacy recruitment, eliminating the use of SATs or ACTs, going test optional, investing and partnering at the K-12 level for recruitment preparation.
This thing's a little bit hot. I'm surprised. I'm really surprised it's a little bit hot. And it literally is only a 1IF transistor radio. It just has a lot of audio gain. But it works really kick-ass, and that little mushroom transistor just brings it all the way home. So anyway, we'll have to take this out on my next rural adventure and see how it actually works. But getting the stations in Baja California sort of makes it a DXer for what it is.